Today we are going to learn about advanced regex techniques for text mining in Python. We'll explore how to extract meaningful information from unstructured text and optimize regex for performance in your text mining projects. Welcome to this session on advanced regex techniques for text mining in Python. Regular expressions, often abbreviated as regex, are essential tools in the toolkit of any data professional working with text data. They allow you to search, match, and manipulate strings with precision. In this video, we will delve into advanced regex capabilities that will enable you to extract meaningful insights from unstructured text data. We'll cover techniques such as extracting keywords, identifying patterns, and optimizing regex performance. By the end of this session, you'll be equipped to handle text mining challenges with greater efficiency and skill in Python.
Regex is a powerful and flexible tool for text processing. In the realm of text mining, it becomes particularly useful due to its ability to identify and manipulate patterns in large datasets. Imagine trying to sift through a massive document for specific patterns or keywords without regex. It would be like finding a needle in a haystack. Regex allows you to define patterns that can match countless variations of a string with minimal effort. Whether it's an email, a phone number, or even a complex pattern, regex can handle it all. Furthermore, Python's integration with regex through the module makes it even more versatile, allowing you to seamlessly incorporate regex into your text mining workflows. By harnessing the power of regex, you can efficiently process and analyze unstructured data, uncovering insights that would otherwise remain hidden.
One of the most common tasks in text mining is extracting keywords and phrases. Regex excels at this by allowing you to define specific search patterns. For example, if you're dealing with customer feedback, you might want to extract mentions of products or services. By using regex groups, you can capture these keywords and phrases efficiently. In Python, you can easily implement this using the module. Let's say you have a block of text and you need to extract all occurrences of a brand name. You can define a regex pattern to match the brand name and use the final function to get a list of all matches. This not only saves time but also ensures accuracy in capturing the data you need. Whether it's hashtags on social media, product mentions in reviews, or any other specific keyword, regex provides a robust solution for extraction, making it invaluable in real-world text mining applications.
Regex is not just about finding specific words, it's also about identifying patterns in text. This is particularly useful when you need to categorize data. For instance, you might want to identify different types of phone numbers or email addresses within a dataset. Regex allows you to define patterns for these structures and categorize them accordingly. In Python, you can use regex to implement these pattern checks with ease. By defining a pattern for, say, a US phone number, you can quickly scan a document and extract all matching numbers, categorizing them under a specific heading. This ability to identify and categorize patterns is crucial in data cleaning and pre-processing, especially in projects involving large volumes of text data. It ensures that data is organized and structured, facilitating easier analysis and interpretation.
In advanced regex, non-capturing groups and lookaheads are powerful techniques that enhance efficiency in pattern matching. Non-capturing groups, denoted by, allow you to group parts of a regex without capturing the match for future use, which can be useful when you want to apply quantifiers to a group but don't need to retain the matched text. Lookaheads, on the other hand, are zero-width assertions that check for the presence of a pattern without including it in the match. They are defined using the syntax, equals. For example, if you want to match a word only if it's followed by another specific word, a lookahead is ideal. These techniques are particularly useful in scenarios where you need to optimize your regex for performance, as they avoid unnecessary captures and checks. In Python, implementing non-capturing groups and lookaheads is straightforward, and these tools can significantly enhance your ability to handle complex text mining tasks efficiently. Working with multiline text poses unique challenges in text mining, but regex offers solutions to handle these effectively. When dealing with multiline data, such as paragraphs or logs, you need regex patterns that can span across multiple lines. Python's regex module provides the multiline flag, which alters the behavior of start, and end, anchors to match the start and end of each line, rather than the entire string. This is particularly useful when you're dealing with structured logs or multi-paragraph formats. For instance, if you need to match a keyword at the beginning of each line in a paragraph, using the multiline flag ensures that your regex pattern applies to each line individually. This capability is crucial in real-world scenarios like log analysis, where data is often formatted in multiline entries. By mastering multiline text handling with regex, you can enhance your text mining workflows and extract more detailed insights from complex data structures.
Regex is a powerful tool, but without careful optimization, it can become a performance bottleneck, especially in large datasets. To optimize regex for performance, it's important to avoid common pitfalls such as excessive backtracking, which occurs when a regex engine attempts multiple paths to find a match. One strategy is to use non-greedy quantifiers, which reduce the number of iterations required to find a match. Additionally, precompiling regex patterns using read.compile in Python can improve efficiency by reusing the compiled pattern. Balancing complexity and efficiency is crucial, Complex patterns can be powerful but may slow down processing if not optimized. Consider breaking down complex patterns into simpler, more manageable components. In practice, these optimization techniques can make a significant difference, allowing your regex to run faster and more efficiently, especially when processing large volumes of text. By understanding and applying these optimization strategies, you can ensure that your regex-based text mining processes are both powerful and performant.
Regex is powerful on its own, but when integrated with Python libraries, it becomes an even more formidable tool for text mining. Libraries like Pandas and Beautiful Soup can be used in conjunction with regex to enhance your text processing capabilities. For instance, Pandas provides functions like str.extract and str.contains that allow you to apply regex patterns directly to data frame columns, making it easier to manipulate and analyze structured data. Beautiful Soup, commonly used for web scraping, can extract HTML elements, which can then be further parsed and refined using regex to capture specific data points. This integration is particularly useful in scenarios like scraping websites for data, where HTML parsing and regex work hand in hand to extract and clean data efficiently. By mastering the integration of regex with these Python libraries, you can tackle a wide range of text mining challenges, from data extraction and cleaning to complex pattern recognition and analysis. Regex is not just a theoretical tool, it has numerous real-world applications in text mining across various industries. In data cleaning and preprocessing, regex plays a crucial role in removing unwanted characters, formatting text, and ensuring data consistency. For example, in the financial industry, regex can be used to extract numerical data from unstructured reports, while in healthcare, it can help identify patient data patterns. Case studies demonstrate regex's versatility, from enhancing search engine results to filtering social media content for sentiment analysis. These practical applications showcase regex's ability to transform raw text data into actionable insights, driving better decision-making and strategic planning. As technology advances, the role of regex in text mining is expected to grow, with innovations in natural language processing and machine learning further enhancing its capabilities. By understanding and applying regex in real-world scenarios, you can unlock the full potential of text mining and stay ahead of future trends.
In conclusion, mastering advanced regex techniques is an invaluable skill for anyone working in text mining. From extracting keywords to optimizing performance, regex provides a powerful toolkit for handling unstructured data. We've explored its applications across various industries, demonstrating its versatility and effectiveness. As you continue your journey in text mining, remember the importance of practice and continuous learning. Utilize resources and tools to refine your regex skills and explore new applications. With dedication and curiosity, you can harness the full potential of regex, unlocking valuable insights from complex text data and driving innovation in your field.